Okay, in this video we're going to talk about how many solutions you can find for a quadratic equation. The answer is there's always two. If you have an x squared equation, there are always two solutions. But sometimes they aren't as obvious as others. Because you see, if I'm going to graph an x squared equation, there's lots of different setups for it. But basically one of three things has to happen. Either when I graph an equation, it's always going to be a parabola shape. Okay, it's always going to be this U shape, and it can be pointed up or pointed down. It doesn't matter. But that, if it's going to equal to 0, it means it needs to, when you're talking when is it equal to 0, that means when is it crossing this horizontal line. When is it crossing the x-axis? And every U shape can do one of three things. Either it can just come down and barely touch the x-axis, in which case we have one time on this parabola that it's equal to 0, which means there's one solution. Sometimes we can draw a parabola that doesn't touch at all, and if that's the case, there are no real solutions. It's never equal to 0. Not with real numbers, at least. We'd have to involve i's, square roots of negative numbers. And sometimes it just so happens to cross twice, in which case we have two solutions, and then they're really obvious. These are the easy ones. So these are the trickier ones, and we're going to talk about how can we figure out, just right off the bat, how can we figure out what kind of answers we're looking for. And that's called using the discriminant. So basically, if we go back to the quadratic formula, we know the quadratic formula looks something like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. And out of this entire gigantic quadratic formula, the only thing that we're really concerned with is what's inside of here. Not even the square root, just what is the b squared minus 4ac. So if we can rearrange an equation into this format, ax squared plus bx plus c is equal to 0, which all three of these already been done, right? If we can rearrange in this format and we look at just the b squared minus 4ac, that turns out to give us quite a bit of information. So without solving, if we're just going to determine how many and what kind of solutions we have, if they're real or imaginary, do we have one, do we have two, do we have no real, what's going on? This is the method. We have to determine that a on this one is 1, b is 4, and c is a negative 1, right? Once we determine that, we go b squared minus 4ac. Let's figure out what that is. Well, let's see. That would be then 4 squared minus 4 times 1 times negative 1. That would be 16 plus 4. Notice that it's plus 4, right? Negative times a negative. Negative 4 times 1 is negative 4 times a negative 1 becomes a positive 4. 16 plus 4 ends up being 20. And all that means is that if I were to go through and do all this work up here, which I'm not going to do, but if I were going to, that I would end up with something blah, 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 plus or minus the square root of 20 all over something else, right? I'd have a plus or minus the square root of 20. Now that's not nice and neat. It's not like a square root of 16 or a square root of 25, but it is a real number. Therefore, I'm going to have two solutions. Something plus the square root of 20, something minus the square root of 20. In other words, anytime you end up with a number here that is greater than 0, you're going to have something to put in here, which means you have two solutions. Two real solutions. Let's go on to the next one. What happens over here? Let's see. A is a 4, B is a negative 12, and C is a positive 9. So as I go through and I do this problem, let's see. B squared minus 4ac. Am I going to have a plus or minus square root of something here to work with? Negative 12 squared minus 4 times a, which is 4, times c, which is 9. And 12 squared is 144. Notice the negative goes away. Minus, and if I do it on my calculator, 4 times 4 times 9, I get 144 as well. That equals 0. Which means if I were to do this entire equation, which I'm not going to do, I'm not interested in that right now, but if I were to solve for this, I would have negative b plus or minus the square root of 0 all over something else, right? That's what that really means. But if it's plus or minus the square root of 0, if it's plus or minus 0, there's really no reason to have this in, right? Why would you do plus or minus 0? And notice what you're left with. One answer. No plus or minus anymore. So if we ever get a discriminant of exactly 0, not positive like we did over here, positive numbers mean 2 real solutions. A 0 for the discriminant means you have 1 real solution. You might remember in the previous video that ended up being 3 halves. We actually did that problem. You could even do it with fractions, okay? And you're going to see how easy this is in just a second. A is 1/3, B is a -2, and C is a 4. And so I go through and I do b squared minus 4ac. See, that would be a -2 squared minus 4 times 1/3 times a 4. -2 squared is 4. Notice the negative goes away. 4 times 4 is 16, and 16 divided by 3, we'll just call it 16/3. 16 over 3. Which, by the way, that ends up being, let's see, 16 divided by 3 ends up being 5.3 repeating, okay? And what you can see here is that if I take 4 minus 16/3, or 4 minus 5.3, whatever you want to do, I end up with a -4/3. It really doesn't matter what the number is. What you know is it's negative. And what happens then is this. That means that I would have in my equation something plus or minus the square root of a negative number all over something, right? And the only thing that's important is the fact that that's a negative number. And guess what? Square roots of negatives. Those cause problems, don't they? So I end up with imaginary numbers. No real solutions, which really means 2 imaginary solutions. That's really what that means. And it turns out then, if we want to compare to the graphs, here's what I can tell you right off the bat, okay? That if I were to look at the graphs of these 3 things right here, see if I can move it down so it's all in the shape, that I know there's only one solution. If I were to go graph this equation right here on my calculator, it would only touch once. I guarantee you. Why? Because the discriminant was 0. It would look like this, right here. Promise you. And if I went through and I did, let's stick it up here. If I went through and I graphed this equation right here on a graphing calculator, or by hand, I would have 2 real solutions. I know the graph would look something like this. It would cross the line twice. And the only way that I can have no real solutions is to have a negative number on the inside, and that means that the graph, when I do it, it won't cross the axis. Now, it may be right side up, and may look something else like that, but I do know that it's not going to hit the axis. And that's all from doing just b squared minus 4ac. Now, if that makes sense, then you're ready to move on to complex numbers.